Welcome back, everyone, to Keeping Current, the podcast from ERS and HVM, designed to plug you into the world of electrical power systems. I'm your host, Joe O'Dwyer, and in this episode, we're exploring what really happens behind the scenes when your power system fails. Joining me today is Dennis Salzmann, Senior Director of ERS Operations, and Dennis brings operations perspective on how outages unfold, how recovery happens in real time, and what it takes to strengthen your resiliency across today's critical infrastructure. So get ready to unplug and connect. Welcome to Keeping Current, Dennis.
Hey, thank you, Joe.
Well, glad you're here. Let's start at the beginning. When every outage has a near miss or starts somewhere, Dennis, from your experience, what are the most common operational factors that trigger failures or disruptions?
Well, I mean, that's a pretty broad, I'll say, topic there, right?
Yes.
Every failure or disruption kind of takes its own course and can kind of go different directions, even somewhat dependent upon the facility, whether it be maintenance or whether it be personal failure, human error type stuff that can trigger your stuff. And so I think some of that is really dependent upon the environment and or the system itself. And I'm trying to think of different things to go along with that, right? But, if you've got a system that doesn't have a lot of maintenance, that's going to be one trigger to a failure. If you have a system that is not, you don't have a lot of training and you got new people trying to operate your system, that could be one cause of a disruption. So I think, Like I said, there's multiple factors that go into that.
That's interesting because so often it's not just one big thing, but I've noticed it's sometimes a chain of smaller issues that add up. So how do you see those small problems escalate into larger issues if they're not addressed quickly or in the beginning?
So I'm going to kind of piggyback off the question itself, and then I'll go into kind of more of the answer. If we look at this from like a safety perspective, right, you always kind of think of like Swiss cheese. And all it takes is one hole, all those holes have to line up correctly for a safety incident to happen. I think it's the same thing when we're talking an electrical failure or a failure or disruption in the power system, is all it takes is one little thing you got to get them all lined up. And if you can just get one of those to unline, and you can kind of slow it down or kind of stop it. And then when you go back and you look at it from a standpoint of how little things can make big things. I always like to liken it to something that people can relate to in your car, changing the oil. That's a really small task and easy, fairly inexpensive. And if you don't change your oil, what happens, right? Eventually the car is going to break down. I mean, even if you just add oil and you just never change it, or any of your other fluids, your car's not going to last as long. And it will cascade into needing a new engine versus just doing something simple like changing the oil. I think your electrical distribution system is the same, right? Are you doing the little things like preventative maintenance, IR scans, torque checks, operating things, lubricating them? And if you don't do those things, eventually you have to replace your switchgear.
Exactly. Before we go on to my next question, when I was in part of a team running a 125 megawatt power plant, we had a turbine that failed and couldn't get it back online. Well, our systems and our control panels were outside, and it was, right in the Sierra Nevadas. It was sometimes 100 degrees, sometimes minus 10. Well, we had a control board that probably had 300 connections going to it on the left, on the right, on the top, and on the bottom. Well, what occurred was the trace, the conductor trace on the back of the board, we had a crack in it. And the only way we found it was to completely undo all of the wires in the middle of the night, take it to our shop and look at it. And that's how we found it. So I couldn't agree more with you regarding the engine oil and things like that. And what we learned is we needed to climate control our control panels to avoid things like this. So things like this that occur, sometimes they're so far out of the box, it's sort of, humbles you. But that leads me to my next question. Are there early warning signs that operation leaders should be watching for more closely?
I would say it's those small little failures, right? It's breakers tripping more frequently, or you go long periods of time with not having any type of faults or any type of problems with your system. And then all of a sudden you start having little things, just little things happening. Eventually will lead to bigger things. And there was a plant years ago, the operational guy that ran that facility kept trying to tell his folks, hey, you need to do maintenance, you need to do maintenance. And they were unwilling to shut down because of trying to meet their operational commitment. It was a chip manufacturer.
Right.
And then sure enough, it seemed like every 6 months when I first was out in this location, they would have a fault and we'd have to go out and troubleshoot it. And then it turned into something that was happening every couple of months and then every month. And more frequently, they started having problems. And I think that's really the early warning sign to bigger failures.
I would agree. Before we move on, what role do people play in the processes in either preventing or accelerating failures?
This just goes back to probably my Navy days, right? I mean, every time we had an incident, you do an incident review. And even now, when you do like a lot of safety incident reviews, things like that, I would say the overwhelming majority of things that we see wrong are human error. Going back to another situation, it was a utility plant. They burned down the entire section of 4160 GE Magnablast gear. And it was all because somebody rolled the interlock wrong. And so they racked in a GE Magnablast breaker, closed, and it tried to start the motor. And then additionally, and this is a utility plant, the polarity on the relay was rolled. It was an original GEIC relay. And so it took out the transformer differential out in the yard.
Oh my God.
Well, both of those are human errors. The system did exactly what it was supposed to do, right? Yes. The breakers didn't trip because the relay didn't trip, but it didn't trip because it was wired wrong, which is a human error. It's not a failure of the equipment. And I would say an awful lot of the things that we see go wrong tend to be human error, whether it be a maintenance error, an installation error. You think about medium voltage cables, what often fails on a medium voltage cable is the termination. And it's a termination failure because somebody didn't install the termination correctly. Not that the termination went bad. Now, there are environmental things, other things can play into that. But unfortunately, I think human error plays a lot more into some of these failures than we recognize.
I have to agree with you on that. I think your comment about meeting the contract requirements, we had a situation where we had to get our system back online to meet contract requirements. And, we had to do it over Thanksgiving, and we were rushing and we were skipping steps, and everybody was falling over themselves. We missed a step because when we went to press start, we had a failure within the motor because of not only design, but process of the connections and such. So it was a geothermal motor that goes, 2,000 feet in the earth. And there's a lot of things that you have to do right, and only one thing wrong causes the failure. So I have to agree with you on that.
Well, in human performance, right, is you just think about from a human performance standpoint, all the things that are going on in our lives, whether it be having kids or having issues at home, stress at work, all those things create distractions for us.
Yes.
And if we're not 100% attuned to what we are doing at the time that we are doing it, it just leads to little mistakes. And again, it goes back to that Swiss cheese analogy. You make just enough little mistakes, all of a sudden everything lines up, and then I have a bigger problem. Where if my head is just in the game and I'm focused on what I'm doing at the time I'm doing it, I can prevent a lot of these issues.
Our issue was it was over Thanksgiving, and everybody had family in, and and we were all just trying to get home. 10 o'clock at night, we all finally got home defeated, and yeah, it was not a good Thanksgiving at all.
Yeah, it's kind of like that. You never do switching on a Friday, right? You
Right?
never do at the end of the week. You don't energize a system Friday afternoon at 3 o'clock. Why? Because everybody's thinking about going home on Friday, right? They want to enjoy the weekend, and
Yep.
that's the time things are going to go wrong.
Yeah, that's an example of a culture that needs some help right there, for
But,
sure.
well, and another problem with the human aspect of it is, in this day and age, all the trades, us as an industry in the testing world, the plumbers, the electricians, everybody is shorthanded, right? And so you're having to bring in more and more. I'm not going to say, I'll say less qualified, right? You're having to go find people and train them from ground zero all the way up. And so the training aspect is another part where we're putting people out in the field in all industries that maybe don't have the same experience we've had 20 years ago, because we just don't have those people.
Yes, they're few and far between. Few and far between where people have the hands-on as well as the ability to manage and operate. So I couldn't agree more. Well, that's where leadership, Dennis, really comes in, because decisions have to be made sometimes more quickly than we like. How do operations teams prioritize actions when we have multiple risks that are unfolding at once? And I know we've both had those. So how do you deal with it?
Well, I think from a leadership standpoint in this industry, I think the first and foremost thing that you have to prioritize is the safety of people. And taking a step back and realizing that, look, I may not get this up quickly, and doing it quickly may create more problems. So really trying to go, okay, let's evaluate the safety aspect of it. Let's make sure everybody's going to be safe, make sure that we have everything that we need to do this, and then get back online. And if you do it in a controlled, methodical way, odds are it's going to go faster. A lot of times I think we try and jump steps, we try and go ahead, and we just try and get something done. We just try and get it energized, especially in the middle of a fault, right? The system's down, customers are complaining, everybody's in a hurry. And so then you start making bad decisions, which just compound the problem. And so taking a step back, analyzing it from a safety standpoint, and then going, okay, what can I do next to get me to the next step, instead of trying to get to the end? Just take it one step at a time.
Well, that's where, one of the things that I noticed is communication is key. Not only internal with our organization, but also externally with our customers or obviously stakeholders. I've had some issues with that in the past and trying to, smooth some waters. But in your view, what are some of the biggest challenges in those high stake moments?
I'm actually going to just say it's communication in and of itself. I always like to throw out a number, and numbers just get made up sometimes. I believe that a lot of our issues in life, whether it be in a faulty situation, we're trying to get something back online, or just in a relationship, communication is usually, or the lack thereof, or some sort of miscommunication is the crux of the issue. Yeah. And so I think being honest and transparent with your customers, not over promising stuff, and just being realistic, and having those honest conversations of, hey, yeah, we messed this up, or hey, it's taking us a little longer to get this maintenance outage done, so we're not going to miss that timeline. And the sooner you communicate those things. So communicate often, communicate honestly, and just be transparent with it. And sometimes you have to swallow your pride and own a mistake. And I think those are some key issues when you're dealing with customers. And look, we're all human. We all make mistakes. And I think most people are forgiving, not all, but most are really forgiving when you are honest and transparent and just realistic in your communication.
And from your perspective, because I understand that everybody has different views of what an issue is or a crisis is, but in your opinion, what separates a contained issue from a full-blown crisis?
Well, that's a good question. Well, a contained issue, right? Something that we've got our arms wrapped around. We've actually
Yeah.
identified the problem. We'll say that way. Maybe we've identified the problem and we have a solution. Doesn't mean the
Right.
problem is solved yet, or we haven't ended at that solution, but at least a contained solution is one where I've identified the problem and I have a path forward. Where I think full-blown crisis mode is when you don't even know what the problem is and you're
Right.
still trying to figure out what the path forward is.
Again, I go back to that control board because we were out there for over 24 hours straight in just cold weather, and when you're cold to the core, and you have to focus on getting that turbine up, boy, that separates the men from the boys, and we got lucky having a spare board, and once we got that spare board in, we were able to go from, a full blown crisis to, okay, well, now we have a contained issue that we can start implementing our steps. And that's how we address that one. So
Well,
I have to
and I
agree with you.
think the problem with a full-blown crisis is we start to lose perspective and we start grasping at straws. And we lose that methodical approach. The
Exactly.
critical thinking kind of goes out the window. All of a sudden, we just start going, well, what about this? What about this? And sometimes it's really good to, every now and then, in a full-blown crisis, just to take a step back, think about that crisis, and think about what you've done and what you haven't done. Really analyze your indications and the things that are going on, and maybe even bring in some fresh eyes.
It's funny how you talk to professionals in our industry, and, everybody comes from a different background, but all of our problems were very similar.
Very
So,
simple.
so um, now let's talk about the part that everyone feels, recovery. Once things are disrupted, what are the most critical steps operations teams take to safely bring systems back online? I think we just discussed it, stepping back and getting a fresh set of eyes. But what do you think?
Well, again, going back from that contained to a full-blown crisis, right? Once you've contained the problem and you know what the problem is, I think that's the one of a great time to just stop and step back and go, okay, this is the problem. What are our step-by-step situations to get us back online? And thinking about it, like you say, from the safety standpoint, and then step by step, and not just rushing into, okay, because I think that's the trap that people will fall into, right? Oh,
Yes.
there's the problem. They just want to jump right to the end and solve that problem versus taking a step back and going, okay, how do I get there step by step? And,
Yeah.
I think you can create a bigger situation by just trying to jump to the end and not have a methodical approach.
I couldn't agree more. I couldn't agree more. We hear a lot about predictive maintenance these days, and I'm a huge proponent of predictive maintenance. But in order to do predictive maintenance effectively, we have to have just more than one person trying to do it. But in your experiences, how does it fit into building resiliency and reducing recovery time?
But let's go back to the oil in your car, right? If I'm not changing the oil in my car and something goes wrong with the car, odds are I'm replacing an engine. Well, that's going to take time and a lot more resources and finances to replace that engine. Where
Correct.
if I'm changing my fluids, changing the oil, various things like that, odds are whatever is going to fail on that car is not going to be as big as my engine. It's just going to be some other component on the car that is much easier for me to replace, both time and money wise. And so
Okay.
that's where I'll say predictive or preventative maintenance and really maintaining a system, keeping it clean. And the other thing it does for you is it reduces what you're troubleshooting, right? If you never do anything with your system, well, you're kind of starting from ground zero in your troubleshooting. Where if you can go, look, I maintain this all the time, you can start eliminating potential failures. So I think those are the
Exactly.
two big things that you can do for building resilience and reducing recovery times by just doing your preventative maintenance.
Yeah, I'm going to go back to the weather or the temperature deviations. We had a non-condensable gas compressor that was tripping offline, and I would go there and I'd press reset and everything would be fine because I would come in during the day when the sun's hitting it and it's nice and warm and we don't have these problems. These things would only happen at night. And it also happened on a lube oil pump. It was the cold temperature was affecting it. So I had a ex-Navy nuke said, Joe, do me a favor, just go in there and just tighten every screw in there. So I took my Allen wrench and took out 1,000 explosion resistant bolts and went through. And my gosh, I bet you a third of them were like just barely in there. You can pull them out if you just wanted to. And so that led to me going to a client, British Petroleum in Baton Rouge, and they're like, Joe, all of a sudden our wrapper, our conveyor big thing will just stop and just, have an error. I said, that's interesting. I said, tell you what, let's do a little hands-on at neck after break. And I said, let's go through and let's open up and tighten because they were exposed to the heat and the cold being in an open bay warehouse, if you would. And son of a gun, same thing. And they looked at me like, how did you know this? How are you so smart? I'm like, no, I'm not smart. Trust me. This is just a guy getting his butt kicked in the field. And this is just experience. So I think experience goes a long way into adding to what you're identifying, if you would. Yeah. So,
and that's part of the problem. Going back to the people one, right? With less experienced people and turnover and older people retiring, and having a younger workforce,
yeah,
it's less trained, right? They miss out on some of that experience.
I have to agree with you. As the standards evolve like the new NFPA 70B. How have you seen them influence the way operation teams approach strategy and preparedness?
Well, interestingly enough, I'm not sure it has yet, because it is so new. And if we go back and we look at like 70E when it came out, it took a long time. I mean, that came out when I came out in the industry, when I came out of the Navy, in the early 2000s, 70E was a kind of a big thing, but it really didn't get fully implemented for like 10, 15 years later. And now it's just common practice. And I think we're still early enough in 70B of being a requirement and no longer a good practice that it really hasn't made its way down into everything yet. Some of the larger companies out there are really going, okay, we got to get involved. We got to do our maintenance. You're seeing it more, but I don't know that it really has yet.
I think we're a few years away. I don't know about you, but when I was at my power plant, let's just say that we were we had unique ways of working on energized equipment, and not one of them involved PPE.
So that may be a true statement.
Yes.
And that's what I'm saying. With 70B, I think some people, the companies that had a good maintenance program, 70B doesn't affect because they already have a maintenance program. And for those that weren't doing maintenance, it's going to take them a little while to come on board and really follow the process and really take it seriously. But it is an important part of maintaining a safe distribution system. And I think more people will find that it will help them maintain a reliable system, especially when you go back and you talk about the heat environments, right? Things are really cold, really hot. Heat is a killer of everything electrical, dirty insulation, all of that type of stuff really does affect the longevity and the quality and the operation of your stuff. And so the more you can maintain it and get it on a good frequency, the better the system will be.
Dennis, you're well respected, and you've been in leadership positions for a long time and have seen a lot of challenges. What lessons have stood out to you most from managing from outages to close calls? How do you see the similarities between outages and close calls?
Again, I mean, I think this is just kind of more of a summary of the things that we've been talking about, right? The training of people. That I think has led to maybe more close calls or more outages over the years, not having a methodical approach and having some of that lack of experience, right? I think those have been some of the challenges that we're facing today with outages and close calls. And I don't know, maybe it'll just take some time to get more experience in the industry. We lost a lot of experience over the last few years, but yeah, hopefully that answered that.
Yeah, definitely, definitely. And for our end users, our facility managers, directors who want to build a stronger resiliency plan, where's the best place to start?
Well, I'm going to give them two places to start. One is 70B, right? 70B, and if you look at it, it really does mirror NETA. If you look at the NETA MTS standards and the 70B standard, there's some differences, but they're very similar, right? And so I think starting with 70B is a great place. But then I think the next thing that goes along with that, especially for people that don't have a good maintenance program already, I do think bringing in somebody like us, like an ERS, and that we've got the experience, we've got the knowledge, we've been doing this a long time. We can really partner with you and help you build a plan around your actual system to give you a more reliable and bring in an expert, I guess is what I'm saying.
Sure. Well, when you're balancing a budget, and when you're dealing with reliability, with cost and resource pressure is always tough. How do you recommend leaders approach that balance in dollars versus, I'd say, actions or implementing a plan? How do you go? What, in your opinion, what do you think is the best way to go about do that? And I'll add something at the end.
Okay. Well, I think you have to start with safety first, right? Electricity can be dangerous. Something's going to blow up. Something's going to get hurt, and something along those lines, right? So I think you have to start with safety first in your budget, right? And that starts with making sure you got an arc flashing coordination study, and then maybe doing some of the basics, right? Just doing basic clean and inspects, torque checks. You talked about it, right? Turning off your system minimum of once a year, making sure it's clean, and making sure all your connections are tight. And that's a relatively inexpensive option, right? And then another failure point, a lot of times, especially if you look at like medium voltage switches, things that require grease, between the dirt and the grease and not being operated, it comes up. And then you go to operate it, it won't operate. And so I think if you're just trying to balance a budget, right, you take care of your safety first, and then you just do simple things like clean, inspect, and exercise your equipment. I think those things go a long way in making sure that your electrical system, it's very similar to just doing an oil change.
And to add to that, one of the things when I was managing my power plant is form a relationship with your testing company, form a relationship with your contractors that assist you. And the reason for that is because they have a lot of good resource, they have a lot of good experience, and sometimes let's push pride out the window, reach out to them and say, hey, I got this situation, what do you think? Do you have any ideas? Do you have any experience with this? And a lot of times a couple things happen. One, they feel part of your team and are part of the solution and feel good about being included in something like that. And also, they might have the answer that helps you get to where you need to be regarding getting something back online, getting maintenance. I will add, when it comes to 70B, identify what you can do in-house well and what you need your contractors to do to support your efforts. I think that goes a long way in identifying anything that is missing but also I call it a sanity check, saying, okay, I know this isn't part of my world because I don't have the equipment, but if communication goes back and forth between the end user and a testing company or a contractor, I think that's invaluable.
And I agree with that, right? And if you think about that from a maintenance outage standpoint, right? You're going to bring in a company like us to maybe do your primary current injection of breakers, test your cables, do stuff that's a little bit more specialized, take some training. But there's no reason why the end user, our customer, can't do the cleaning of the gear, right? I mean, with us right there, we can help them make sure they got the right cleaners. More than likely, they can run a torque wrench and do the torquing. And so those are some things they can do to keep the cost down and yet still get their equipment tested.
So that was you over my shoulder when I was cleaning arc chutes and wiping down stuff, huh? I didn't know that, Dennis.
There you go.
All right. And finally, Dennis, I promise this is the last question. Any advice you leave for operation professionals who want to prepare their teams for the unexpected?
I'm going to go back to training, right? Plan for the unexpected. If you don't plan for the unexpected, then when the unexpected happens, you're planning to fail, right? So walk through the scenario. Go back to what you were just talking about with, what you can do in-house. There's nothing that says you can't take your own people and walk through, hey, if we have an outage, what do we do? It's almost like a fire drill, right? Be prepared, be planned, and go, okay, this breaker over here trips, or this trips, how does it affect the system? And what do we have to do to get that system back online? Especially if you have real critical systems that if they get shut down unexpectedly, what does it take to restore them in a controlled manner? And practice that. And that way you're prepared for the unexpected.
I couldn't agree more. That's why I ask all my clients, where is your single line drawing in your switchgear room? And then I always ask them, I said, well, when do we need to look at our single line drawings? And somebody will always say, well, when the power goes out. And I said, well, how about we stick an emergency light above our single line drawings so we're not sticking the mag light in our mouth anymore? And that always gets the chuckle. So
well, and what you said earlier about having partnerships, right? If you're using a consistent testing company or an electrical contractor, loop them in your unexpected plan. Right?
yes,
So that you have somebody to call. We talked about having an outside perspective. You're doing your troubleshooting and you're going, something just doesn't seem right. You at least have somebody you can call and go, hey, we had an outage. Can you come out and help us? And you get some more eyes on some stuff.
exactly.
And everybody's prepared to get it.
I agree. Well, Dennis, this was a great session. I can't thank you enough. And thank you for sharing your background and experience. It's clear that there's a lot we can learn from the operations side of these things regarding failures and recoveries. And knowing your background and us knowing each other for many years, I truly do appreciate it. So thank you very much.
And I appreciate you having me, Joe. This was a good time. Thank you.
All right. Well, that's it, ladies and gentlemen, for this episode of Keeping Current. If you found today's conversation valuable, make sure to subscribe and leave us a review. We look forward to the reviews to see how we're doing. And tune in every other Thursday for more expert insights. Until then, connect with us on LinkedIn to stay in the loop. And as always, thanks for listening. Until next time, keep current. Thank you very much.